you can go for full screen mode. Full screen. Fine.
Okay. Okay, let's discuss about the first step. There are two different techniques for improving cache performance. The first one is reducing the miswrite. You should know what is miswrite. A miswrite, the fraction or percentage per access that results in a miss is called miswrite. So how do we reduce the miswrite and increase the improve the cache performance? The first one is reducing the miswrite by reducing the probability that two different memory blocks will contain for the same cache location. Let's see. The two different memory blocks will compete for the same cache location. By reducing that probability, we can reduce the miswrite, which improves the cache performance. And the second technique we had taken is reduce the miss penalty. We should also know what is miss penalty. The difference between lower level access time and cache level access time is called miss penalty. So we have to reduce this miss penalty but for improving cache performance by adding an additional level to the hierarchy. We all know about hierarchy that we had 5 levels in that. So by adding an additional level to the hierarchy, we can reduce the miss penalty. This technique is called multi-level caching, where we had learned before in caching process. So let's go to the third point. CPU time can be divided into the clock cycles. Here, CPU perform two different actions at a time. What operations that CPU do? Let's see. CPU spends executing the program, and the clock cycles that CPU spends waiting for the memory system. Here, the clock cycles of the CPU spend doing two operations at a time. One is executing the program, another one is waiting for the memory system. So as they had given CPU time formula, which we had discussed before, execution clock cycles plus memory stall clock cycles. Here, executing the program is one operation and waiting for the memory system is another operation. Let's see. CPU time equals to CPU execution clock cycles plus memory stall clock cycles. Here, the time between this operation is clock cycle time mentioned here. Let's go to the next point. The memory stall clock cycles come primarily from cache misses. Memory stall clock cycles can be defined as the sum of stall cycles coming from reads plus those coming from write. Here, the CPU performs two main tasks, read and write. What is memory stall? Let's see here. Memory stall cycles per access is defined as the number of stall cycles added to CPU execution cycles for one memory access. Let's see. Here, the memory stall clock cycles is defined as read stall cycles plus write stall cycles, the two operations mainly performed by the CPU. And the read stall cycles can be defined in terms of the number of read accesses per program, the miss penalty in clock cycles for a read and the read miss write. As we had discussed miss write and miss penalty before, and the read stall cycles can be defined as number of read accesses per program. The operation read is performing per program, and read miss penalty and read miss write. writes are more complicated. Let's see why writes are more complicated. Because there is write buffer in writes, so that it's more complicated. Let's know what write buffer. In a CPU cache, a write buffer can use it to hold data being written from the cache to main memory or to the next cache in the memory hierarchy. So it holds the data being written from the cache to main memory. This is also variation of write-through caching called buffer write-through. It will be discussed later in this topic itself. So write means we can fetch the fetch means we can get the block before continuing the write, and write buffer stalls as performed before in the read stalls. The same will be performed here, but at an additional write buffer stalls added, and we can neglect the write buffer stalls in this process. Let's see. Because the write buffer stalls depends on the proximity of writes, so it is very nearer and closer to the writes. Fortunately, it systems with a reasonable write buffer depth. So when a depth of 4 or more words, there will be only the percentage of by a factor of 2 exceeds the average write frequency. So the write buffer is very small. We can safely ignore that. But we have to add in this write stall cycles for providing much accuracy rate. If a system did not meet this criteria, it would not be well designed. If the system did not read these criteria, and these writes and reads does not meet these criteria, it will not be well designed. So the system is not designed well when means if this criteria is not worked. Instead, the designer should have used either a deeper write buffer or a write back organization. You can know what is write back. Write back is a storage method in which the data is written into the cache every time a change occurs, but is written into the corresponding location in main memory only at specified intervals or under certain conditions. Okay, let's see what is write back. It's a storage method. What storage method? In which data is written into the cache and also particularly written in the main memory as the data is stored in cache, and it is stored in main memory as well in the corresponding location, but only at specified intervals. At specified intervals only, we have to store the main memory in the corresponding location of cache. Let's see. Memory stall clock cycles. What is memory stall clock cycles? As we have discussed before with read stall cycles and write stall cycles, in the same way the memory stall cycles will have formula like this: memory accesses by program into memory miswrite into miss penalty. As we have discussed miswrite and miss penalty before, and we can also factor this as memory stall clock cycles. The memory access is in terms of instructions. Instruction by program. Miswrite can be written as misses by instruction into miss penalty. Let's go to the problem that given. Calculating average memory access time. Find the average memory access time for a processor with a 1 nanosecond clock cycle time, a miss penalty of 20 clock cycles, a miss rate of 0.05 misses per instruction, and a cache or access time including hit detection of 1 clock cycle. Assume that the read and write miss penalties are the same and ignore the other write stalls. So they had said to ignore other write stalls, and we have to assume that the read and write miss penalties are same. So let's see what they had been. The average memory access time per instruction is AMAT. The formula is time for a hit plus miss rate into miss penalty. What is time rate here? 1 clock cycle, 1 plus, and miss rate they had given 0.05 misses per instruction. So 0.05 into miss penalty here, 20 clock cycles. So after doing the calculation, 1 plus 0.05 into 20, we got an answer as 2 clock cycles. So we got the average memory access time per instruction is 2 clock cycles. Okay, let's move on to the next topic, handling cache miss. What is cache miss in computer architecture. Let's see. A cache miss is an event in which a system or application makes a request to retrieve data from a cache, but that specific data is not currently in cache memory. So let's see. It's an event or a system or application. To make request, we have to make a request that the missed data in cache should revive. How to revive that? A cache miss requires the system or application to make a second attempt to locate the data, this time against the slower main database. Here they had given it is a request for data. We have to request the data from the cache that cannot be filled. Why? Because the data is not present in the cache. So the requested data is not present in the cache. So we have to make a request for data from the cache that cannot be filled. So what we have to take the steps to follow this? We can now define the steps to take in on the instruction cache miss. So let's see the steps. Send the original PC value to the memory. So we have to send our original PC value to the memory. Next, instruction main memory to perform a read and wait for the memory to complete its access. So we have to instruct our main memory to perform a read. We have to perform the operation read and wait for the memory to complete its access. So we can get the result. Write the cache entry, putting the data from the memory in the data portion of the entry, writing the upper bits of the address into the tag field and turning the valid bit on. So we have to write the cache entry. How? Putting the data from memory in the data portion of the entry, writing the upper bit of the address. We have to write the upper bits of the address into the tag field and turning the valid bit on. Restart the instruction execution at the first step, which will refetch. That means we will get the instruction, this time finding it in the cache. The missed cache, that is the cache miss which is missed, we can get after the fourth operation, which is restarting the instruction execution. After doing all this process, we have to restart the instruction execution at the first step. What we have done at the first step, we have to restart the instruction execution, and we will re-get this, finding it in the cache. So the data will be found in the cache memory. Next, handling writes. What are the handling writes? Let's see. First one is inconsistent. After the write into the cache, memory would have a different value from that in the cache. In such a case, the cache and the memory are said to be inconsistent. So when we store a data in terms of values, the memory would have shown different value in the cache when we search it. In that case, the memory and cache are said to be inconsistent. Write through. What is write through? Let's check it out. The simplest way to keep the main memory and the cache consistent is always to write the data in both the memory and cache. This scheme is called write through. So the simplest way is what? We have to store the data in both memory and in both the main memory and cache memory, so that the data will remain consistent. This scheme is called write through. What is write buffer? Write buffer, as we have discussed before, a buffer stores the data while it is waiting to be written to memory. After writing the data into the cache into the write buffer, the processor can continue execution. So it stores the data when it wants to be written. After writing the data into the cache into the write buffer, the processor will continue execution. So it will continue the execution whenever after writing the data into the cache. Let's check the fourth point in this. When a write to main memory completes, the entry in the write buffer is freed. If the write buffer is full, when the processor reaches a write, the processor must stall until there is an empty position in the write buffer. When the data in the main memory completes, the entry in the write buffer is freed. So it will stop if the write buffer is full. When the processor reaches a write, it should have wait until the empty position in the write buffer. So the data will remain stopped until there is an empty position in the write buffer. The processor must stall until there is an empty position in the write buffer. What is write back? As we have discussed before, what is write back? In a write back scheme, when a write occurs, the new value is written only to the block in the cache. The modified block is written to the lower level of the hierarchy when it is replaced. So in a write back scheme, when you write occurs, the new value is written only to the block in the cache. So it will return only the new value to the block in the cache. The modified block is written to the what will do the modified block is written to the lower level of the hierarchy when it is replaced. So it will be replaced only when it is written to the lower level of hierarchy. Okay, next go to the write back schemes can improve performance. As we have discussed before, what write back is doing. Write back schemes can improve performance and more complex to implement right through. So it will improve the performance and more complexity will provided to implement right through. Right through, as we have discussed before here, the simplest way to keep the main memory. So the data will be stored in both memory and cache to be consistent. So this can improve performance and more complex to implement than write through. Okay, let's check about split cache. A scheme in which a level of the memory hierarchy is composed of two independent caches that operate in parallel with each other. Here, it performs two independent caches at a time parallel to each other. We know parallel to each other, opposite to one another, and very parallel to each other. One handling instructions. These two independent caches, one is doing with instructions, another one is doing with handling with data. So this is all about handling writes. Next, we had given problem. Let's check it. Calculating cache performance. As this process is very simple, I will explain in a simple way. Assume the miss rate of an instruction cache is 2% and miss rate of the data cache is 4%. If your processor has a CPI of clock cycles per instruction of 2 without any memory stalls and the miss penalty is 100 cycles for all misses, determine how much faster a processor would run with a perfect cache that never missed. Assume the frequency of all loads and stores is 36%. So they had all given the data. Let's check it out. Miss rate 2% and miss rate of the data cache is 4%. If a processor and a CPI clock cycles per instruction is of 2 without any memory. We should remember this point in the problem. Clock cycle per instruction without any memory stalls. So this is used in this point is used in this problem. Let's check it out where. So let's start the problem. The number of memory stalls, memory miss cycles per instruction in terms of instruction count is instruction miss cycles equals to instruction count into instruction cache, miss rate of instruction cache 2% into miss penalty 100 cycles per all misses. So instruction count into our miss penalty into miss rate. So that is 2 into I. After doing this calculation, we'll get this. As the frequency of all loads and stores is 36%, as given in the data. The frequency of loads and stores is 36%. We can find the number of memory miss cycles for data references. So we have to find the data miss cycles. Data miss cycles equals to I. Instruction count into, they had given frequency into, and the miss data cache. Here we are discussing about data miss cycles, so we have to take data miss rate of data cache 4% into miss penalty. They had given 100 cycles and 100 cycles. After doing this calculation, we'll get 1.44 into instruction count. I is written as I. So let's check next step. The total number of memory stall cycles is 2 instruction count plus 1.44 instruction count, as we got this both instruction miss cycles and data miss cycles. So the total number of memory stall is instruction miss cycles plus data miss cycles. The total we got 3.44 instruction count. This is more than 3 cycles of memory stall per instruction. According to the total CPI, clock cycles per instruction, including memory stall. As we have discussed, this will be very much helpful if the processor has CPU of 2 without any memory stalls. So we have to include the memory stalls in the total clock cycle per instruction. So these 2 will be added to the total number of memory stall cycle. So here's what they had given. 3.44 is what we get, and this 2 should be added because without any memory stalls we don't want, because we want total CPI. So we added 2 to the our total 3.44 plus 2, that equals to 5.44. Instruction count. Since there is no change in the instruction count or clock rate, the ratio of CPU execution times. So they said they have to neglect all the other things. There is no instruction count or no change in clock rate. So the ratio CPU execution times can be written as CPU times with stalls by CPU times with perfect cache. So what we get is CPU time with stalls, with memory stalls, and CPU time with perfect cache they had given before. CPI without any memory stalls is 2. This is CPI perfect, and we have to get CPU time with stalls, and we got this 5.44. Let's check it out. What answer? I into instruction count into CPI stall into clock cycle, instruction count into CPI perfect into clock cycle. So we have to remember the formulas here and there, and I cancel, clock cycles cancel with, and the remaining is CPI stall by CPI perfect. What we got? CPI stall we got 5.44, CPI perfect as they had given in the problem 2 without any memory stall. So this is CPI perfect. So 2. After doing this calculation, CPI stall by CPI perfect 5.44 by 2, that is 2.72. So the performance with the perfect cache is 2.72. As this topic is very simple and easy, as this is totally based on mathematics and formulas and the little concept, and this is over. If you have any queries, you can ask now. Right.
Yes, Teja Babu, brilliant presentation. Very good presentation. Fine. I have covered most of the topic very well. Formula, everything is explained perfectly. Yes, students, encourage your friends by chat box. If you have any doubt, you can post it. Any queries? Unmute and reply. Yes, kindly answer the queries. Teja Babu. Can you hear me?
Now, they had given query, how is AMEC useful? Average memory access time useful. Average memory access time is a useful measure to evaluate the performance of a memory hierarchy configuration. It will evaluate the performance of a memory hierarchy configuration as we have discussed. It tells us how much penalty the memory imposes on each axis. So on average, it tells what? It tells about how much penalty the memory system imposes, and it can be easily converted into clock cycles for a particular CPE. Is that okay, Geeta?
Good. Any other queries? So this material what Teja Babu has presented, all are having those materials, right? I have sent that. The material what I have sent only you have present, right, Teja Babu?
Ma'am.
The materials what I have sent. No, I have to know that all are having those materials in their hand. Perfectly explained, sir. Explained, Teja Babu. No doubt about it. I'm just asking
Thank you, ma'am.
students that whether Teja Babu have to forward his presentation, I mean that notes to all the members.
Ma'am,
Or
I will forward the definitions, extra definitions
Yeah, sure.
in the group, ma'am.
Fine. You can pass that in the main group itself. It's again the CSC group itself. Fine. Any doubt, students? Kindly encourage your friends. How was his presentation? Is it satisfied by all? Kindly encourage by your yes chat message. Brilliant presentation done. Short duration covered most of the topics and the definitions, formulas of measuring and improving the catch performance. Perfect presentation. So I think it's the right person has assigned for this mathematical calculation. All the students kindly encourage your friends by messaging in the chat box. I hope all are listening to the seminar. So kindly message and encourage your friend. Sure, Teja Babu, you are going to get placed in a very big MNC company, conveying the information correctly and clearly.
Thanks, ma'am.
Okay, all the very best for your future. Okay, any other doubt we can wind up or okay, see your friends encouraging words. Yes, Babu, Teja Babu, you can forward your definition, your materials, what you have presented to your friends. If they ask any doubt in personal also, you clear it.
Okay, ma'am. Sure, ma'am.
Okay. Okay, any other thing, students? Is it okay for today's class? Tomorrow, whose presentation is that? Hey, Surya, can you note
Yes,
down the
ma'am.
absentees?
Can you hear me, ma'am?
Yes.
Ma'am, tomorrow presentation is by Nazneen and Archana C, ma'am.
Fine, good. Archana C. Archana C is there in the link now?
Okay, ma'am.
Yes, ma'am.
Archana C,
Yes, ma'am.
can you please send your CA answer script?
No, I've sent it.
No, you have sent PQT.
Oh, I'm sorry, ma'am. I will send soon.
Okay, no issues. It happens, but you should be a little bit cautious, okay? During unanswered exam, they're asking for this type of sending the documents. You should be very much careful, okay?
Okay, ma'am. Sorry, ma'am.
Okay, no issues. We are ourselves giving way for reducing marks or like that. Okay, this happens even for third years. They have just sent some other document of paper. But hereafter, don't repeat. And I have put,
Okay.
I have corrected the papers. Okay, Teja Babu, can you just stop presenting? Yes. See, kindly students note down the marks. And meanwhile, Jay Surya, note down the absentees.
Okay, ma'am.
Fine. Your marks are in front of you. Okay, I have mostly given more marks for all the students. Few students have not given some examples for 2 marks. That's why I have reduced it to half marks. And few students have not presented the diagram for the particular part B questions. So reduce little marks. Okay, so these are your marks. I send you in the group. Just go through. And don't ask for extra marks. If I have, see, a few people, see, Archana, see, also I have given marks. You just see to that you have attended those questions. Yes, you have not sent the correct documents. Okay, automatically I have to send some marks immediately. This asked by your class in charges. Those listed students, I have sent in Hasha WhatsApp message. 5 students. Name Archana C, Archana M, Nitik Roshan, Anna Malay, and Logavashini didn't write the exam due to some personal issues, I know. These 5 members kindly resend your CA answer script to my WhatsApp number immediately, as soon as possible. Okay, I send the data. Just go through your marks. Why Hasha very late? Hasha, can you hear me? Hasha, unmute and reply. Hashavardhan, can you hear me? See, you have left you have missed your friend's good presentation of the topic, measuring and improving the performance of catch. So you should not miss those things, right? Each and everything you have to make is tips. Okay, how our friend has been presented, same follow up, and we also have to improve that. So don't miss those sessions, seminar sessions. Fine. Okay, we'll wind up. Jaiswari has taken the attendance. Thank you for your cooperation. Good presentation again. Okay, you can leave the session. Thank you, students.
Thank you.
Thank you, madam.
Thank you. Fine.